Section 9.3, hyperbolas. So this is our last conic section that we are going to be looking at. And we've got some more formulas to look at, but let's look at the definition of the hyperbola first. Hyperbola is the set of all points x, y in a plane. The difference of those distances from two distinct points are called the foci is constant. So set of all points x, y in a plane, the difference of whose distances from two distinct fixed points called the foci is a constant. Let's look at what that means here. If I have, this is an example of a hyperbola. All right, so a hyperbola is basically two sections, and they're each parabolic, and they each also have a focus here and here. Well, if I find a point on the parabola here, on one part of each section of the hyperbola, the distance between this point and this point, the two focus, their distances are, if you find the difference, so let's go D2 here and D1 here. If I do D1 minus D2, it equals some constant, and that constant is the same no matter where this point is. So if I put this point on the other side, or even down here, the difference between these two segments is also C. If I put the point here, the difference is the same. Doesn't matter where that point is, it can rotate around. It can be on either section, top or bottom. Standard form, you got two different standard forms. The main key here is that the standard forms are subtraction of. So either you do the squared x's minus the squared y's, or the squared y's minus the squared x's. Now if the y's are being squared, or I'm sorry, let's do the x's first. If your x's are being squared, then your hyperbola opens left or right. So it would look like this, left and right. And if your hyperbola begins with your y squareds, then it opens up or down. Unlike the ellipse, the a squared is not necessarily bigger than b squared. In fact, the a squared is always just listed first. A squared will be listed first. The center is HK. This is an important piece of information. All right, you also have something in here that's called the transverse axis. And the transverse axis is this. If I have a parabola or hyperbola, both parabolas opening up and down, then the transverse axis is the distance between this vertex and this vertex. These are both vertices. And this is the axis right there. And if it is opening left and right, then the transverse axis is from vertex to vertex. That's the axis. So this is a horizontal axis. And this is a vertical axis. All right, let's look at the foci. The foci is C units from the center, and the foci will lie inside the two parabolic sections. So again, if I have my parabolic section opening like this, And like this, I have a center point here, and then the foci here and here. This is the center. This is how the C value is found. The C value is the distance from the center to F, or the focus. That is C units. See, this just means center. It is found by a squared plus b squared. So now with the ellipse, it was a squared minus b squared. But now with the hyperbola, it's a squared plus b squared. I remember it because the signs are backwards. The ellipse you're adding in the formula. So with the ellipse, you subtract a squared b squared. Now the hyperbola, our main form here, you can see, is you're subtracting. So for the focus, you add in the formula. All right, your asymptotes. Now here's how you find the asymptotes of the hyperbola. Asymptotes, again, are two lines, or they are lines that your graph slowly approaches but never crosses. Each hyperbola have two asymptotes that intersect at the center. Here's the equations for them. Let's look at what they look like, though. If I have a hyperbola that opens to the right and to the left, like this, then the asymptotes cross through the center and are lines that the graphs slowly approach but never cross. These are the asymptotes. And here's how we're able to find them. If the hyperbola is horizontal, so if it opens horizontal like this, then you have your k value, plus and minus b over a, and then x minus h. If it's vertical, so if it's opening this way, then it's k plus and minus a over b, x minus h. This is just putting it into somewhat of like a point slope form. All right, let's look at our first example. So it says, find the standard form of an equation of a hyperbola with foci -1, 2, and 5, 2. Well, I always will graph these out. -1, 2, and 5, 2. With this being said, I know that my center has to be what? That's what you should ask yourself. Where's the center? Well, the center is halfway in between these two. So the center is at 2, 2. HK is 2, 2. Which I also know that the hyperbolas are going to be opening left and right. And if they open left and right, then I'm looking at x minus 2 squared as listed first, and the y minus 2 squared is listed second. Again, I know that they're opening left and right because of where the foci are at. Okay, the vertices are at 0, 2, and 4, 2. 0, 2, vertex, 4, 2, vertex. All right, so the A value is going to be how far the vertex is from the center. Well, the vertex right here is 2 units. They're both 2 units away from the center. So if they're 2 units away, then A is 2, which would conclude that A squared is 4. So it's x minus 2 squared over 4. Now the y's. The y, I would need my b squared. Well, I don't know my b squared. I do know my c, and my c is the focus. And the c is where the focal, how far the focus is from the center. Well, the center to the focus right here is 3 units away. So then we know that c squared is 9. So I can find my b squared because c squared equals a squared plus b squared. And so here I've got c squared is equal to 4 plus b squared. And my c squared is 9. So 9 equals 4 plus b squared, or 5 equals b squared. B squared is 5, so b is the root of 5. All right, we got all of our important parts, and here's how we write our equation. So I know that this is opening left and right, so it's horizontal, and the equation would be y equals, the k value is 2, plus and minus. I do b over a, root of 5 over 2, and x minus 2. Now here's how you do the asymptotes. The asymptotes look like this. I always do a slope. Okay, so I went from my center, we go over 2 to get to my vertex, or to get to my vertex. I also can go up the square root of 5, which is about a little more than 2. And then down the square root of 5, a little more than 2. If you create a little box here, and that box is through each vertex and through the a and b values, or that's how far away they are, then if you connect those with the center, then these are the asymptotes. Now, with that being said, then you come back and you draw your hyperbola to slowly approach those asymptotes. Looks like this. And there you go. The main thing is that you always want to create the slope of the asymptote, and the slope of the asymptote is going to be the rise to run value. So either b over a or a over b, it's going to depend on the direction that your parabolas are opening. In this case, each parabola is opening left and right to get the full hyperbola, so we will do b over a. All right, example 2. Find the standard form of the equation of the hyperbola and sketch the hyperbola whose equation is 4x squared minus y squared equals 16. So it's not in that right form. We need to divide by 16. If you divide by 16, you get 4 over 16, which is x squared over 4, minus y squared over 16 equals 1. So let's sketch this. I know that my center is the origin, and it's going to open to the right. So 2 units here is my vertex, 2 units to the left. These are my a values. My a is 2. Now I create my asymptotes from going 4 units up. That's coming from the square root of 16 and 4 units down. And you create this box. This is going to get my asymptotes in line. These are the asymptotes. They go through the corners of the box and through the center. So now that I can draw my hyperbola. Here, here, each side. Okay, there's the drawing of it. Now let's label some of these parts. So I know that a is 2, b is the square root of 16, which is 4. I can find c because c squared equals a squared plus b squared. So the c would equal the square root of 20. C is 2 square roots of 5. 2 square roots of 5. So my standard form, again, is x squared over 4 minus y squared over 16 equals 1, and the asymptotes would be y equals I need my k value, and the center was at the origin, 0, 0. So it's 0 plus and minus, so I can just do plus minus, and since it opens to the right and to the left, then what I do is I do my b value of 4 over the a value of 2. Well, 4 over 2 is 2, and then x minus 0, or just x. Basically what you're dealing with is this is the equation of both of those diagonal lines. And that's it. That's the hyperbola. And there's your assignment.